This is the first video produced that is showing a newly found titanium meteorite. It was found near Redmond, Oregon, in the high desert. Its weight is 1,252 grams. It has a length of 125 millimeters. It has a height of 65 millimeters and a width of 76 millimeters. It's composed of 89.7% titanium, 2% chromium, 6% iron, and 2% tin. Now, today it is the understanding of the meteorite scientific community that titanium meteorites simply do not exist. They have not been found in the past, and the scientific community does not expect them to be found in the future. But this object came either from Earth sources or it came from space, and we know that titanium is not found on the Earth in elemental form. It's not found as a metal. Titanium on the Earth is found only in the form of titanium ore called ilmenite. Ilmenite has a very small percentage, 1 to 3% of titanium atoms in it, and the titanium has to be extracted using electrolysis. There is no other foundry process for extracting the titanium. It cannot be extracted through volcanic processes, through hydrothermal. There is no place in the Earth or on the Earth where titanium metal is found. Knowing this, the first reaction of some of the scientists that I spoke to, they suggested that if I had such an object, it must be a piece of titanium slag. But what we find out is, in industry, there is no such thing as metallic titanium slag or solid titanium slag. Titanium slag is a hot, molten mixture of ilmenite. There is no cool titanium slag. There is no waste, because every single atom in the ilmenite is extracted using electrolysis. And thus there is no industrial waste of the titanium. Another scientist suggested that it must be industrial waste then. Well, titanium was first extracted from ilmenite in 1950, so 70 years ago. And it was very expensive. The first titanium was very expensive to extract, way too expensive for anyone to consider scrapping or throwing it out. And so we obviously have a piece of naturally occurring titanium. And because we find no source for natural elemental metallic titanium on the Earth or in the Earth, we need to start looking at space for the possible origin of this find. Now, even though we are suggesting that it could have come from space and is in fact a meteorite, it does not fit the description of a metallic meteorite as we know them today, because mankind has never seen a non-iron nickel metallic meteorite. Every meteorite that we have ever witnessed shares the characteristics of an iron nickel meteorite. The characteristics that it acquires as it comes through the outer atmosphere, as it experiences heat ablation, as it experiences a smoothing of the outside due to the heat and ion plasma flow. In the case of this sample, this is rough on the outside. It's rough and shows evidence that the roughness are in fact impact marks, impact sites that would have existed on this piece when it was in outer space, and somehow it made it to the ground without losing these details, these scars. NASA proved to us 52 years ago that titanium does not ablate. It does not wear as it's coming through the atmosphere. It does not melt. It does not erode away. It does not smooth out. Titanium comes through our outer atmosphere, heating, but not changing physically. And it lands much as it was in outer space. How do we know this? Well, NASA actually created heat shields out of titanium, and they successfully reached the ground without any melting or ablation. We also now today have thousands and thousands of pieces of satellite rocket technology framework that has reached the ground successfully without ablation. All of these pieces are made out of titanium. The iron that was attached to the framework, the iron has ablated. The aluminum is totally gone. It just disintegrated. Some of the stainless steel made it to the ground, but overall, titanium is the one element that was not affected. by atmospheric entry. So this is the first video in a series where we introduce what we believe is a titanium meteorite. In the following videos to come, we will show detailed evidence that indicates that this is in fact a meteorite. So I hope you tune in for the others.